Welcome to học tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, today we read story number 59, Knocking Electrons with Light. During his work with what we now call radio waves in 1887, Heinrich Hertz noticed that it was easier to make sparks jump across the gap between his electrodes if they were radiated with ultraviolet light. He had put his apparatus in a darkened box so that he could see the spark better, with a glass window to look through. But he noticed that the sparks would not jump across as big a gap as when the electrodes were not in the box. When the glass window was taken away, leaving a hole, the sparks were able to jump as before. By trying windows made of different substances, he worked out that the glass was absorbing ultraviolet light and that this was responsible for the effect. Although Hertz published his results, he did not suggest any explanation for the effect, and he did not carry out further experiments to investigate it. Other people did investigate the phenomenon, in particular the Russian physicist Alexander Stoletov. But the key experiment that led to an understanding of the phenomenon was carried out by Philippe Lenard in 1902. Lenard had worked as an assistant to Hertz in Bonn, but by then he was established as a professor in his own right at the University of Kiel. He was carrying out a major investigation of cathode rays, electrons, and wanted to find out if the effect discovered by Hertz was a result of ultraviolet light releasing electrons from a metal surface. By shining ultraviolet light on a clean metal plate in a vacuum tube, he was able to produce cathode rays, which could be manipulated by magnetic and electric fields in the usual way. But the particles leaving the metal surface traveled so slowly that they could be stopped and made to fall back by a small electric potential. The speed of the particles could be measured by the strength of the electric field needed to make this happen, and this led to Lenard's most profound discovery. I have also found that the velocity is independent of the ultraviolet light intensity. It would have been natural to expect that a brighter light would make electrons move faster with more energy. But increasing the brightness only produces more electrons, each with the same energy. Further experiments show that changing the frequency or wavelength of the light does affect the energy of the electrons. Light with a higher frequency or shorter wavelength produces electrons with more energy. Light with lower frequency, longer wavelength produces electrons with less energy. In 1905, the same year that Lenard received his Nobel Prize, Albert Einstein found the explanation. He suggested that light exists in the form of packets of energy or quanta, which became known as photons. On this picture, electrons produced by the photoelectric effect are ejected when a single photon strikes a single atom. Each photon striking an atom gives up all of its energy to the ejected electron. What we think of as higher frequency light is made up of more energetic photons. So when a higher frequency photon hits an atom in a metal surface, a single electron is released with the same high energy as the incoming photon. A brighter light just carries more photons with the same energy, so releases more electrons with the same energy. Similarly, for light of a particular frequency, a fainter light carries fewer photons, so it releases fewer electrons, but still all with the same energy. Einstein's suggestion that light could somehow be both a particle and a wave was received skeptically. After all, the evidence of the double slit experiment still stood. The American physicist Robert Millikan was so outraged that he spent 10 years carrying out a series of difficult experiments aimed at proving Einstein was wrong, only to conclude that light quanta were real. It is worth quoting his own comments. After 10 years of testing and changing and learning and sometimes blundering, all efforts being directed from the first towards the accurate experimental measurement of the energies of emission of photoelectrons, now as a function of temperature, now of wavelength, now of material. This work resulted, contrary to my own expectation, in the first direct experimental proof in 1914 of exact validity within narrow limits of experimental error of Einstein equation. Einstein's Nobel Prize, the 1921 Physics Prize, held over until 1922, was awarded specifically for his services to theoretical physics, and especially for his discovery of the law of the photoelectric effect. In 1923, Millikan received the Physics Prize for his work on the elementary charge of electricity and on the photoelectric effect. As these awards show, the discovery of photons was a key step on the road to quantum theory, where the concept of wave-particle duality proved crucial in developing an understanding of the behavior of atoms and subatomic particles. Now to the vocabulary section. Electrodes, absorb, absorbing, surface, shining, manipulate, manipulate, potential, potential, velocity, velocity, intensity, intensity, frequency, frequency, wavelength, wavelength, quanta, quanta, photon, photon, faint, fainter or faintest, skeptical, skeptically, skeptical, skeptically, outraged, mad, outraged. Well, thank you for your time, and as usual, I will see you in the next story. Bye for now.